back. Today we're going to be talking about Venn diagrams and sets. So let's go ahead and get started with that by taking a look at a few vocabulary terms. So here we're talking about set and set relationships. A set is a collection of numbers named by a capital letter. So for example, we have set A here, and inside set A is 2, 5, 6, 9, and 10. We have elements, and an element is each number or member in the set. So for example, our set A of 2, 5, 6, 9, and 10 have the elements 2, 5, 6, 9, and 10 are all the elements of set A. Now let's take a look at three different types of sets. So the three types of sets that we're going to talk about are infinite sets. That's any set with an unlimited number of elements. And we show that as set B, for example, inside the braces, 1, 2, 3, 4, ... an ellipse showing it goes on forever and never repeats. We have finite sets, so that's any set with a limited number of elements. So we've got example set C here with 4, 5, 6, 7. It has no ellipse and no indication that it goes on or that there are other elements. The last type of set is an empty set, and that is any set that has no elements. We have notation for that with either braces that has nothing in it or a 0 with a slash through it. Now let's talk about how these sets interact. There are two main types of interactions that we're going to be talking about for our sets purposes. Are there other interactions? Yes, but we're going to deal with just these two: unions and intersections. A union is the collection of all of the elements in two sets. So the notation looks like a giant U for union. This means the union. So for example, in set A is 1, 2, 3, 4, and set B is 2, 4, 6, 8. Then the union of A and B is going to be 1, 2, 3, 4, 6, 8. So we just take all of the numbers that we had in each set and add them together. Intersection, on the other hand, is the collection of elements that the two sets have in common. And this notation looks like a giant upside down N, or not an upside down N, a regular N. This means the intersection. For example, if set A 1, 2, 3, 4 and set B had 2, 4, 6, 8, then the intersection is 2 and 4 because those are the only numbers that they have in common. Now let's take a look at a few examples. So here we are at example A, and it says use the Venn diagram to determine each set described. So we've got to figure out on the left-hand side A union B, and on the right-hand side A intersect B. So for A union B, we're going to be looking at things that encompass all of A and all of B. So if we look at that, it's going to include every number that we see except for this 8 that is in neither A or B. So when we're talking about A union B, we know that's going to include all of the numbers 1, 2, 3, 4, 5, 6, 7, and 9. Then when we're talking about A intersect B, we're going to be looking for only the numbers that are between A and B, that they share, that they are common. So we're first going to delete, let's get rid of this pink so that we can see what we're talking about here. So we'll get rid of the pink here. And then we want to look for numbers that are only common. So the only numbers that are common are the ones where there is interlapping between A and B. The interlap between A and B happens here, between A and B in the middle. So those numbers are 1, 5, and 7. So A intersects B at 1, 5, and 7. Now let's take a look at the next example. So here in example B, it says shade the Venn diagram to show each set described. So we're going to color in the parts that it's asking us that match the examples here. So we've got A union B, so we need to color everything that's included in A and B. So we're going to color all of A in this blue. All right. And then it's a union of A and B, so it's everything all together. So then we're also going to color this B completely. So that colors A and B, so that is A union B. On the other side, we've got to draw the intersection of A and B. So we're only going to color the parts where A and B intersect, so that is the middle. So we're going to shade right here in the middle because that is the area where A and B intersect. Now let's take a look at example C. So here we are at example C, and it says shade the Venn diagram to show each set described, but this time we've got 3 circles, A, B, and C, and we've got something down at the bottom where it says it wants us to find where the union of A and B intersects with C. So notice that we've got these two letters here in parentheses, so it's asking us to find the union of A and B first, and then figure out where that intersects with C. So if you remember in the last problem we did, when we had to find the union of A and B, it was all the circles of A and B. So if we had A and B here, we know that we'd be coloring all of the circles because that's the union of A and B. But we can't just color all of the circles this time because it's not just asking us for the union of A and B. It's asking where that union, that giant part where we would shade there, intersects with C. So if we're looking at all of A and B being colored, but only where that union is going to interact with C. We've got to figure out where that's going to be as far as C is concerned. So C, we know, is going to intersect here with A, and it's going to intersect here with B. So when we're coloring all of A and all of B, but we're looking for when they intersect with C, it's going to be this section here, because we notice that there's some of B here over here in the B section, right, is intersecting with C, and the A section that's intersecting with C is this side here. That should be a different color. There we go. All right, so we can see A intersecting here. So that is the area that we are going to shade, because we can see the A is in blue, we can see the B is in purple, and we can see the C here is in orange. So that's the area that we're going to shade. So we're going to shade it with red, because that's one of the colors I haven't used. So we're just shading this section here, because this is the union of A and B intersecting with C. It's not coloring all of A and B together and then just drawing an intersection of C. We have to figure out where that union took place and how does it interact with C. That brings us to the end of this example. It also brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.